Einstein's Truancy. I mean, what a title for a blog post, right? It's definitely provocative. Today, we're going to dig into its central idea that there's a century-old trick hiding right in the heart of modern physics. And get this, we can supposedly uncover it with 3D modeling software. Okay, let's jump in.
So just think about this for a second. What if a regular 3D modeling tool, the kind of thing you'd use to build a world for a video game, could actually peel back the layers on one of the most famous theories in all of physics and reveal a hidden trick? Well, that's exactly the question this one blogger sets out to answer. And according to them, the whole key to understanding this supposed mistake boils down to how we perceive a simple shape, just like this one. It's all about perspective.
And that brings us to the real heart of the argument. This idea of two completely different perspectives, which the author calls God's view versus our view. So the whole thing starts with a simple cube, but it's viewed in two fundamentally different ways. On the left, you've got the cube as it truly is, this perfect, objective map of its own reality. But on the right, that's the cube as we would see it, distorted, subjective, and totally shaped by our own limited point of view. Yeah, this slide breaks down those two perspectives perfectly. On one side, you have the design space. Think of that as the blueprint of reality. It's that God's eye view where everything just exists all at once, totally objective. But then there's the camera eye. That's our view. It's subjective, it's limited, because information like the light from that cube has to physically travel to us. That means it always arrives over a period of time.
So here's the crucial point. Our camera eye isn't infinitely far away. It has a specific location in space, coordinates. And what that means is if we change our position, the cube's appearance completely changes with it. The underlying reality, that map, it stays the same, but our view of it is totally dependent on where we are. And this illustrates the consequence of that camera eye view just brilliantly. For us to see the entire cube at one single moment, light from different parts of it, say the corner closest to us and the corner farthest away, had to have left at different times to all arrive at our eye at the same time. What we perceive as an instant is really just a collection of old news.
Okay, so what happens when we throw motion into this model? Well, that brings us to the next part of the argument, the illusion of speed. And this is where things start to get really, really interesting. The author introduces this key concept here, apparent speed. Now, this is not the constant speed of light, see, not at all. Instead, it's the speed an observer perceives light to have when they themselves are moving relative to that objective design space where the light is actually traveling.
Okay, so the author uses this really simple diagram to illustrate a pretty wild idea. Imagine you're on a train and it's moving at 60% the speed of light. Meanwhile, a beam of light shoots past you vertically, at light speed. Because of your own forward motion, your camera eye perceives that beam of light as moving diagonally. And according to the author's math, this makes its apparent speed way faster.
And that apparent speed is 1.166 times the speed of light. Now, I know what you're thinking. That directly contradicts a core principle of special relativity. But in the author's model, it's just a logical consequence of separating that objective design space from the subjective camera eye of a moving observer.
So how does any of this apply to the real world? Well, the author takes this model and uses it to revisit a very famous experiment, framing our own planet Earth as a speeding train. This 3D model is really the centerpiece of the whole argument. It's the author's reinterpretation of the famous Michelson-Morley experiment, which was a real-world test, by the way, back in the 1880s. It was designed to measure Earth's motion through a supposed ether that light was thought to travel in. So in this model, the experimental device is on a train, that's the Earth, moving through a static field, which is our objective design space.
Now check this out. According to the author's model, something very strange happens inside this moving train. The apparent speed of light actually changes depending on which way you look. Light traveling with the train's motion seems much slower, while light traveling across it seems faster. The key takeaway here is that from the observer's perspective, the speed of light is no longer a constant. That is a direct challenge to a foundational idea in physics.
So where did physicists go wrong, according to this blog post? The author claims it all started with three classical assumptions: that time flows the same for everyone, that light starts from the center of a moving object, and, crucially, that this light should hit the walls of that moving object all at the same time. It's this last belief, the author claims, that's the setup for the entire trick. And that brings us to the final reveal, uncovering the trick, which the author says is really all about confusing the map with the journey. Here it is, the core of the alleged mistake, right from the author's own words. They claim that physicists were, quote, thinking of the plane at x equals 6 in the electromagnetic frame as if it were the plane at x equals 0 in the interferometer's own frame. In other words, they were mixing up coordinates from two completely different points of view.
So the whole thing boils down to this. The trick, according to this analysis, is mistaking the observer's moving viewpoint, their subjective, limited perspective, for the absolute static map of reality. It's all about confusing the camera eye with the design space.
So what's the big takeaway here? According to the author, the trick at the heart of modern physics isn't really a flaw in the math, but a flaw in our thinking. This whole analysis is a powerful reminder that we have to be so careful not to confuse our subjective view of the world with the objective reality it represents. It's a perfect illustration of that old saying, the map is not the territory. And that leaves us with a pretty fascinating question to think about. I mean, whether you agree with this analysis or not, it really forces you to ask, how much of what we accept as physical reality is just a trick of our own very limited perspective?